Hello everyone, in this module we are going to learn about NumPy data types and attributes, and we are going to cover the data types object in NumPy Python. After this we will discuss the NumPy array attributes. So let's start with the first topic, that is data type object in NumPy Python. Basically all the elements of a NumPy array are data type object, and it is also known as D-type. A data type object implements the fixed size of memory. It gives us the information about the type of data, that is integer or you can say a float, and also it gives us information about the size of data. So to get the data type of a NumPy array, we use the dtype function that always return the data type of an array. So we can create a data type object by using the following syntax. NumPy.dtype is the attribute name, and within this attribute we have used few parameters. The first parameter is object. It represents the object which is to be converted to the data type. The next parameter is align. It can be set to any boolean value. If it is true, then it adds extra padding. The last one parameter is copy. It creates another copy of the dtype object, and by default it takes false value. Now we will discuss and understand the important data types which are used in NumPy. The first data type is integer. This is the default data type of an integer, and it is identically to long type in C because that mainly stores 64 or 32-bit integer, and it is used to represent numeric number, for example 2356. An integer occupies a fixed number of bytes, for example the type of np.int32 that occupies exactly 4 bytes of memory. These are also called as primitive types because they are not object, they are just data bytes that store directly in memory. Now the list of integer data type is given in the following table. So when it comes to the 8, 16, 32 or 64 that follows the int, it can vary based on the processor in the CPU, or you can say how much memory you would like to allocate for the data type. But if you are trying to execute some basic program, then I will suggest trying to use the smallest data type that can correctly store and represent your data. Smaller data types are usually faster because they use less space on the disk. So the int 8, 16, 32 and 64, these are the bit integer, and the range values is given in the table. Now the unsigned integers. Unsigned integers are similar to normal integers, but they can hold non-zero values, and here are the available types, that is uint 8, uint 16, uint 32 and uint 64, and these are the 64, 8, 2-bit, 32-bit integer, and the range value is given in the table. Basically the advantages of unsigned data is that it can represent larger positive numbers. Now we will understand our next data type, that is floating, and it is basically used for representing decimal number, for example 12.5, 78.9. The list of floating data type is given in the following table. The first one is float. It is similar to float 64. That means it is double precision float, and it contains 11 bits and 52 bits are used for Magnesia. The next one is float 16. This is used to specify the half precision float, and it is a 5-bit exponent. The next one is float 32. This is used to represent the single precision float, and it is an 8-bit exponent. Now we will discuss our next data type, that is complex number. A complex number consists of 2 points number. One is real point and another one is imaginary point. So this is the various data types of complex number. The first one is complex, and it is similar to complex 128. The next one is complex 64. It is a single float precision in complex number in the form of imaginary and real numbers. The next one is complex 128. It is similar to complex, and it represents 64 bits. Now let's see example for better understand the concept of data types. In this example we have constructed a different data type object, that is int, float and complex. The first one data type is integer number. To do this task, first we have imported the NumPy library with the alias name np. After that we have created an array by using the np.array function and assign the integer values in it. And now we will check the data type by using np.int64, that is the integer data type. After that we have used the print statement and assigned the employee ID variable in it. For checking the array creation, for checking the data type. The next one is floating number. Same in this case, we have created an array and assigned the integer values and set the dtype parameter and use the np.float64 data type. After that, we have used the print statement and assigned the customer ID variable. The next data type is complex number. We have created a variable product ID and assigned np.array function. Within this function, we have assigned the integer values, and along with that, we have used the dtype parameter and set the np.complex64 method. And after that, we have used the print statement and set the command print and set the variable product ID. Now I will execute this code and it will show the creation of array, integer data type and floating data type, that is decimal points. After that, complex data type and the real number and the imaginary number. Now we will discuss and understand the NumPy array attributes. Basically, array attributes are important to find out the shape, dimension, item size and size. Let us look at some of these attributes with their respective example as well. The first one attribute is np.shape. This attribute returns the dimension of the array and it is a tuple of integer that indicates the size of your NumPy array. For example, if you create a matrix with n rows and m columns, the shape will be n cross m. In the case of one dimension array, they do not have columns and rows, so the np.shape function returns a single value tuple. So here is the syntax of NumPy.shape. NumPy.shape is the attribute, and within this function there is only one parameter, that is array, that indicates a. Now let's see example for understand the concept of np.shape. In this example, first we have imported the NumPy library with the alias name np. After that, we have created an array with the name instructor id and used np.array function. After that, we have used the print statement and print the statement creation of array with set the instructor id name. Now we will check the shape of a given array by using np.shape function. Now I will execute this code. After executing this code, it displays the array shape, that is 7. That means it consists 7 elements in the array. Now we will discuss and understand the next attribute, that is ndim. This attribute helps find the number of dimension of a NumPy array. For example, 1 means that the array is one dimensional, 2 means that the array is two dimensional. So here is the syntax of ndim. nd array is the array and ndim is the attribute. There is no parameter in this attribute. Now let's see the example for better understand the concept of ndim attribute. In this example, we have just simply created an array by using np.array function, and within this function we have set the 2-dimension array. After creating an array, we have used the print statement and displayed the result, and now we have to check the dimension of a given array. To do this, we are using the ndarray.ndim function. In this case, ndarray is the country ID. After executing this code, it displays the creation of array and along with that the array of dimension, that is 2. That means it is a 2-dimension array. Now the next attribute is ndarray.item size. This attribute helps to know the length of each value of an array in bytes. So here is the syntax of item size. Now we will understand the example of this attribute. In this example, we have just created a simple array by using np.array function, and within this function we have set the dtype parameter and assigned the np.int64 integer value. After creating an array, we have used the print statement and display the array. Now we have to check the item size of a given array, and to do this we are using the item size attribute along with the ndarray, and in this case ndarray is product ID. After executing this code, it displays the creation of array and the item size of array, that is 8 per byte. Now our last attribute is ndarray.size. This attribute is used to measure the total number of values which is available in an array. So here is the syntax of ndarray.size. Within this attribute there are no parameters in it. Now let's see example for better understand the concept of this attribute. In this example, we have created an array by using np.array function. After creating an array, we have used the array.size attribute to get the size of an array. After executing this code, it displays the array size is 6. So with this we have completed data types and attributes of NumPy array. In the next module we will learn the working of NumPy arrays.